Imagine you're sitting under a tree and an apple falls on your head. Why? That simple question sparked a revolution in how we understand the universe. Welcome to classical mechanics, the science of how things move. Let's rewind back to 2,000 years ago. Aristotle believed that objects needed continuous force to keep moving, and that they would stop as soon as the force was removed. But in the 1600s, Galileo's experiments showed that things keep moving unless something stops them. He rolled balls down ramps and realized that in the absence of air resistance, objects of different masses fall at the same rate under gravity. Drop a feather and a hammer on the moon, and they hit the ground at the same time because there is no air resistance. This led to the birth of classical mechanics, often considered the foundation of physics. In 1687, Isaac Newton published Principia Mathematica, a groundbreaking book in which he explained the 3 laws of motion, from the falling apple to the motion of planets. His key insight? Forces and motion are deeply connected. The first law of motion, inertia. An object won't start or stop moving unless something pushes or pulls it. Think of a parked car. It won't budge unless it is forced. The second law, force equals mass times acceleration, where force is the push or pull on an object. Mass is how much matter the object has, and acceleration is how quickly the object's speed changes. Push a shopping cart lightly, and it speeds up a little. But if the cart is heavier, you'll need to push even harder to get the same result. The more mass something has, the more force it takes to accelerate it. The third law, action and reaction. For every action, there's an equal and opposite reaction. Rockets lift off by pushing fire downward, which pushes them up. But classical mechanics isn't just about forces. It's also about energy. When you kick a soccer ball up a hill, you give it energy because it starts moving. This is called kinetic energy, the energy of motion. Kinetic energy is equal to half of an object's mass times the square of its velocity. As long as an object moves, it has kinetic energy. As the ball rolls uphill, it slows down, and some of its kinetic energy is converted into potential energy. Potential energy is the energy something has because of where it is. For example, when the ball is higher up, it has more potential energy because gravity can pull it down. Potential energy is calculated as mass times gravitational acceleration times height, where gravity is the pull, and height is how far the object is above the ground. Another way to describe motion is with momentum, which is how much oomph something has while moving. A fast tennis ball has some momentum, but a truck going the same speed has much more because it's heavier, which is why it's harder to stop. Momentum equals mass times velocity. Momentum, motion, and forces also apply to gravity. Gravity moves planets around the sun using circular motion. The bigger something is, the stronger its pull. Everything pulls on everything else with gravity. That's why we stay firmly on the ground, and why planets don't fly off into space. Welp, that's all the brainpower for today. Please like, subscribe, and leave a comment to recharge.